Check it.
Okay, welcome back. Today we're going to be graphing logarithm functions. Now, last time we learned that logarithms are the inverses or the opposites of exponentials, and now we're going to be able to graph them as well. Now, a quick review of graphing exponentials. If you have a function y equals some base to the x, the way we've been graphing it, we kept it simple. We just used -1, 0, and 1 for our x's, and then we took that base to these powers. So here you got b to the -1, which would just be 1 over b to the 0, which is just 1, and then b to the first power, which is just b. And we did that, and then we applied shifts and stretches and things to that. But that was basically it. This was a simple table with 3 x's to worry about, right? And that was it. Now, logarithms are the inverse of this. So if we want to graph a logarithm, let's see how would we graph the inverse of this table. First thing you want to do is use the swap method and find the inverse of y equals b to the x. The way to find the inverse would be to swap the x and y. So this becomes x equals b to the y. I swap the x and y, and now I have the inverse. Now, let's write this as a logarithm. We know how to change these into logarithms from the last lesson. We will have, well, actually this is written backwards, so let me just put the x on the other side here. We will have log base b of x equals y. So this becomes log base b of x equals y, but I'm going to put the y on the left side here. So here we had y equals b to the x, with the base being b. Here we have y equals log with x, with the base being b. And since these are inverses, the tables should be almost exactly the same, except for one thing: the x and y should be swapped. So the -1, 0, and 1 on the left here should be -1, 0, and 1 on the right here. And the b to the -1, b to the 0, and b to the first should all be here, but on the right, on the left side, right? So this should be b to the -1, b to the 0, and b to the 1. So my point is this: if you're graphing a logarithm, it's exactly the same as graphing the exponential with the same base, just flip the table around. Now, to highlight this, let's do two functions on the same graph. Let's do y equals 5 to the x, okay? So there's no shifting here, there's no stretching, it's just nice and simple. -1, 0, and 1, okay? 5 to the y is 5 to the power of x, so we're going to take these x's and plug them in for the power here. So this is 5 to the -1, which is 1/5. This is 5 to the 0, which is 1. And this is 5 to the 1, which is 5. And that's y equals 5 to the x. And you want to, oops, not 5x, 5 to the x. Now, if you want to graph that, okay, let's do this one in red over here. It's -1, 1/5, so back 1, up 1/5, that's right about there. 0, 1, which is right about there. And 1, 5, 1, up 1, 2, 3, 4, 5, that's right about there. And hopefully you see your half parabola right there. And on the other side, you land the plane along the horizontal asymptote there. Okay? And that is your y equals 5 to the x function. Now, let's graph y equals log base 5 to the x. Now, these are inverses. So if you know the table of this one, you already know the table for this one. Okay? It's the same table, just in the opposite, swap the x's and y's in the opposite direction. So instead of the x's being -1, 0, and 1, the y's will be -1, 0, and 1. And instead of the x's being 1/5, 1 and 5, instead of the y's being that, the x's will be 1/5, 1 and 5. All right, and let's graph this now. We'll do this in a different color. We'll do this in blue now. Okay, so 1/5, -1. So over here, we'll go to 1/5 of a box over to the right, and then down 1. So that's around here. We have 1, 0, which is actually right there. and 5 comma 1. So 1, 2, 3, 4, 5 comma 1 is right here. And hopefully you see another half parabola, but this one's going, instead of vertically, it's going horizontally, or like that. And here you're going to land your plane, but this time it's a vertical runway instead of a horizontal runway. Still an asymptote, still can't touch it. And there it is. Now, because they're inverses, they're supposed to be reflections across the line y equals x, which looks like this. And that line y equals x right there is the mirror, okay? And these should be symmetrical with respect to that line. And you can tell that they are, right? They are mirror images of each other across that line. So visibly you can tell that they are inverses, and numerically you can tell they are inverses. And we know before we even started that these are inverses. So this is how you graph a logarithm, this blue function right here. Basically, you figure out what the base is, which in this case is 5. You use your same -1, 0, and 1, but you put the y's on this side here. Let's try another example. And by the way, here's a Desmos version of that same graph, just so you can see a perfect one right there. All right. Okay, so for this one we have log base 2 of x. All right. And if this were an exponential, it would look like this, y equals 2 to the x, and you would do a graph starting with -1, 0, and 1 on the left side. But because this is a logarithm, all right, you're going to do almost exactly the same thing, but you're going to put the -1, 0, and 1 on the right side like this. Now, what's the base? The base is positive 2. And since your base is positive 2, you're going to take each one of these to that power right there. So 2 to the power of -1 is 1/2. 2 to the power of 0 is 1. And 2 to the power of 1 is itself 2. And now there aren't any shifts or any stretches, so we can just put this directly on our graph here. So 1/2 comma 1, go half a box over and up 1, no, sorry, down 1, -1, down here. 1 comma 0, that would be here. And 2 comma 1, 1, 2 comma 1 is right here. And what you're looking for is that half parabola shape, and there it is right there, if you can see it. And you notice it's going to the right. Now, exponential functions used to go up this way or this way. Logarithmic functions will be going either this way or this way, because they are inverses. All right, so we do have to land the plane here, okay? But now that everything is kind of rotated 90 degrees, our runway isn't horizontal, it's going to be vertical, and you still have to be careful not to touch the runway to keep getting closer and closer without curving back out. Don't curve back out in any way, okay, because that'll be wrong. That'll be marked incorrect. So if you're doing this sloppily and you kind of do that, I'm going to mark this part wrong because you're not coming back away from the runway. All right, so be careful. All right, so here we go. And put your arrow on the end and you're done. That's all there is to it. Really simple. Okay, let's try one with a fraction for a base. So once again, we're going to make our table. If this were an exponential, we'd be putting -1, 0, and 1 on this side. But since it's a logarithm, we're going to put -1, 0, and 1 on this side. Now, take the base. Remember, it's all about the base. You find the base and you work with that. 1/3 to the -1. Well, 1/3 to the -1 just means a flipped 1/3, which is 3 over 1, which is 3, right? And then 1/3 to the 0, anything to the 0 is 1, and 1/3 to the first power is itself 1/3. So there's your table. No shifting, no stretching, so we can just go ahead and graph it. All right, so we have 3 comma -1, so 1, 2, 3 comma -1 will be down here. 1 comma 0 would be here. And 1/3 comma 1, so 1/3 of a box is roughly there, comma 1 would be right about here. And now what we're looking for is that half parabola, and you can see it's going this way this time. And on the other side, of course, we do need to land the plane. And there it is. Okay, so let's see what we do when we have a stretch. So this one is a log base 2, but there's also a stretch right over here. Okay, you have a dilation constant, aka a stretch, which is going to vertically stretch the function. Okay, so once again, you're going to make your table. You're going to put your -1, 0, and 1 on the right side. Take the base, because remember it's all about that base, no trouble. All right, so 2 to the -1 is 1/2. 2 to the 0 is 1, and 2 to the 1 is itself. Now, if you have a stretch, just like you did with the exponentials, you're going to multiply the y column with that number. So we have a stretch of 3 here. Multiply all of these by 3. Now, this is done after you've filled in your entire table. Okay, so this is going to be -3, 0, and +3. Okay, and there's no shifting to do, so we're ready to go right to our graph here. We're going to go to 1/2 on the x, so that's right about there, and down 3, that's right there. Here we're going to go 1, 0, which is right here. And here we're going to go 2, 3, so 1, 2, and then up 1, 2, 3, that's right there. And it's really wide, or rather tall, because of the shift, but it's still a half parabola going this way, like that. So just do your best to draw yourself that half parabola. And then land the plane on the other side, best you can. And you are done. Okay. Let's try something with a shift now. All right. Now let's just talk about the shifting here. For an exponential, you had y equals b to the x. That was the parent function. If you had a stretch, the stretch was over here as an a, just like it is here. Okay. If you had a horizontal shift, it was up here with the exponent, right? So it was x minus h for horizontal shift. And if you had a vertical shift, it was down here as a k. Now, with logarithms, it kind of works the same way, but you need to use parentheses. Logarithms, if you have a vertical shift, so y equals log base b of x. And once again, if you have a horizontal, if you have a stretch, it's over here as an a, just like we had for the exponential. And if you have a vertical shift, it's over here as plus k. But if you have a horizontal shift, well, how do you know that this is not a horizontal shift? Parentheses. You're going to be putting this in parentheses with the x. And there you go. That's where the minus h goes. Now, this might remind you of parabolas. With parabolas, parent function is y equals x squared. And what we had is if there was a stretch, it would be a in front of the x squared, like that. And then your horizontal shift would be inside parentheses with the x, and then your vertical shift, if you have one, would be outside like this. So the inside the parentheses thing is your horizontal, the outside is your vertical. It works the same way with logarithms. So this right here, you might say, is this a horizontal or a vertical shift? This is vertical because it's not in parentheses with the x. On the other hand, let's go down to the next example here. This one has a horizontal shift there of left 3, and this is up 2. And we have a stretch of -2, which is also a flip because it's negative. All right, we'll come back to that one in a minute, but let's come back over here. So hopefully this was enough of a review to make you understand what's going on. So let's just back up here. All right, so what's happening right here? We have a shift of down 2, and we have a stretch, a dilation of 3. Okay, +3. Okay, so let's make our table. Now, when we make our table, we can ignore the vertical shift and the stretch until the end. So let's just make our table here. We're going to put our -1, 0, and 1 just like before. We're going to look for just the base now, okay? Just the base. No trouble. And take it to the -1 power. We get 1/8. 8 to the 0 is 1, and 8 to the 1 is itself 8. Then we stretch. Okay, there's a 3 on this, so 3 on all of these. -1 times 3, 0 times 3, and 1 times 3. And now for the shift, instead of adding a shift or subtracting a shift from here, we just move our axes on the graph because we have to graph the axis anyway. So let's see, this is down 2, which means the horizontal axis is going down 2. And just like we did with exponential functions, just draw your shift rather than worry about putting it on the table. Okay, so there it is. And we'll make this into a dotted line as we need to. Okay, there it is. Now, one thing I want to point out is that on an exponential function, this horizontal axis is an asymptote that you cannot pass through. On a logarithmic function, it's the vertical axis that is the brick wall you can't pass through. So this is not a horizontal asymptote. This is, this is just a horizontal axis. It's the vertical, which is still the y-axis because we're not moving it. This is your vertical asymptote. So we're going to have a function that either does this and asymptotes against it this way, or does this and asymptotes against the other side. One or the other, one way or the other, your vertical axis is your asymptote. So there's no horizontal. You're going to pass through this red line, and you'll see that in a moment. Okay, here we go. So 1/8 comma -3. Now 1/8 is really going to be hard to show here. So here's 0, 0. This is our new 0, 0 right here. 1/8, okay, there's 1/2, there's 1/4, 1/8 is really, really close. Comma -3, so down 1, 2, 3 from this new center. We'll just say it's over here. It's not perfect. And now the next one is 1, 0. Okay, once again, from this new 0, 0, 1, 0 would be right here. And finally, the last number is 8, 3. All right, do I have 8 boxes here? 1, 2, 3, 4, 5, 6, 7, 8. Wow, just on the edge there. Comma +3. 1, 2, 3, which would be up here. Okay, so where's my sideways parabola? It is that thing right there, which I completely missed. Let me do that a little bit more carefully. Okay, and then I need to land the plane, right, against the asymptote. Now, once again, this is a vertical asymptote. You don't touch the asymptote, you don't go through it, or you don't bounce off it, and you also don't go away from it either, so don't do that. And draw your arrow at the end there. Okay, and there you go, your first shifted logarithm. Okay, let's try one more, and we'll call it a day. Okay, so we already looked at this one. We decided that this is a shift of left 3. It's left because all horizontal shifts are the opposite sign of what they appear. So this says +3. You're going to go back to -3. This is up 2 for the vertical shift. And there's a stretch, which is negative. So this is actually going to be upside down. So let's take a look. The first thing I'm going to do this time is actually put down the axes first. So up 2 would be an axis here, a new x-axis here. And to the left 3 would be, let's see, 1, 2, 3 to the left, down here. And I'll make all of these dotted lines, of course, because they have to be dotted. Okay, so now that we have our axes laid out, let's make our table. X and Y, -1, 0, and 1 on the right side. What's the base? The base is 1/4. 1/4 to the -1 is an upside down 1/4, also known as 4/1 or 4. 1/4 to the 0 is 1, and 1/4 to the first power is itself. There you go. Now there's a shift of -2. So you're going to multiply everything by, sorry, not a shift, a stretch of -2. Multiply everything by -2. See what we get. We get -1 times -2 is +2, 0, and -2. And that's it. You're going to graph these on this shifted axis, and you're done. Now, if you look at the book will say, okay, subtract 3 from all the x's and add 2 to all the y's, and that would put you, but you still have to draw your axis. So what's the point? Draw your axis and then just use the basic table. It's a lot easier. Okay, so 4, 2. Starting from here, starting from our new 0, 0, go 1, 2, 3, 4, and up 2, and that puts you right there. The other one was 0, 1, so that would be right here. All right, and the last one was 1/4, -2. All right, so 1/4 of a box, that's half, that's about a fourth, and down 2, so somewhere right about there. And hopefully you can see there is a sideways parabola there. Okay, so do your best to draw it. All right, until the edge of the graph, and then on the other side you want to, land the plane, which is all the way down here. Once again, the challenge is not to slam into this or to curl back up. So be careful not to do either of those things. And put our arrow on the end. And that's what it looks like. Okay. Now, to be honest with you, this looks a little too straight here. Maybe this should be more like that. So I will fix that. Okay. These are curves, not lines. So you want to make sure that they don't look straight as much as possible. I know it's hard to not be straight when you're asymptoting against a long distance like this, but do your best. Okay guys, that is it. I'll see you at the next video.